Hi, I'm going to help solve for the sum of the series from n equals 0 to infinity of the quantity of 4 plus 3 to the n all over 5 to the n. So this one looks a little bit tricky because it looks like a geometric series, and it actually is, but it just looks a little bit tricky, at least at first glance. It stumped me for a little bit. So the first thing that I tried to do is I tried just splitting this out to 4 over 5 to the n plus 3 to the n over 5 to the n. And from here, I was stumped for a second before I remembered a property of series. So when there's a summation inside a series like this, we're actually able to split this into two series. So what this works out to is basically two geometric series added together. So I'm going to split this up into the series from n equals 0 to infinity of 4 over 5 to the n plus the series from n equals 0 to infinity of 3 to the n over 5 to the n. Now, this first one is the same as the summation from n equals 0 to infinity of 4 times the summation of n equals 0 to infinity of 1/5 to the n. We're able to bring the 4 out front, and then 1 over 5 to the n is the same as 1/5 to the n, because 1 to the n is always going to be 1. Then we're going to add to this the series from n equals 0 to infinity of 3/5 to the n. So now I'm just going to kind of split this up just to show what's going on here. And I'll write this up here just as a reminder. The sum of a geometric series is C over 1 minus R, where C is the first term. And R is equal to what's brought to the power of n. So like for this one, R is 1/5. For the second series, R is 3/5. Now for the first series, C is going to be the first term. So n to the 0 n being set to 0 is 1/5 to the 0, which is equal to 1. 1 times 4 is 4. The first term in that series is 4. C equals 4. So it's going to be 4 over 1 minus R, which is that 1/5. Plus, for this one, the first term, when n equals 0, you set n to 0, 3/5 to the 0 is 1, so C is equal to 1. So 1 over 1 minus R, which is at 3/5. From here, we're going to get 4 over 4/5 plus 1 over 2/5. This is equal to 4 times the reciprocal, so 5 over 4. The 4s are going to cancel, and we'll be left with 5 on the left, plus the reciprocal, which is 5 over 2. Just to make this a little bit easier, I'm going to put 5 over 2 for the left term, so multiplying that by 2, we're going to get 10 over 2 plus 5 over 2, which is equal to 15 over 2, which is also equal to 7.5. So that's how you use two geometric series to solve the summation from n equals 0 to infinity of the quantity of 4 plus 3 to the n all over 5 to the n. I hope this was helpful.